Welcome back, my friends. Yes, today we're going to be talking about low pass gates, okay? So we're going to I'm streaming this, so we'll see what happens, okay? So I'm going to start off by looking at this PDF here, all right? This PDF it comes from the Buchla book that we were looking at the other day. Called Alan Strange's Electronic Systems Controls Technique, something like that. And obviously it's about the booklet, so it'll tell us what. There's one lovely picture in it that I want us to see. This is my second favourite picture in all of music technology. If you ask, I'll show you my first. But I love this one. It's by David Rosenboom, and we're going to hear a quote from him in a minute about low-pass gates. And I love how it shows 4 human brains. So it's portable gold and philosopher's stone, music from brains in 4 by David Rosenboom. And so you got 4 brains, and you measure their galvanic skin responses and all that stuff. You put them through clock dividers, and you signal routing. And then there's an envelope follower and a low pass gate. And then it goes into some Fourier analysis. It's a very interesting 1970s look at, what they thought the future would be like, and they were correct. So we'll look now at what a low-pass gate is from what Buchla is. It's right here. This is what a low-pass gate is. So Buchla didn't have standard VCAs or filters. He had this, a low-pass gate. And what it is it's a quad low-pass gate, so it's 4 of them. And the module consists of 4 independent gates, each of which has 3 possible operational modes. The mode switch in the upper position turns the gate into either a low-pass filter, into an amplifier, voltage control amplifier, or in a third position you can have both, a low pass gate and amplifier. Okay, so that's what it does. And I'm going to read you now a little bit of what David Rosenboom said about it. He worked with Don Buchla for a while. So he said, according to him, the primary intention behind the low pass gate was about creating a controllable sense of distance and movement in space. The more open or excited the gate becomes, the closer the sound will seem to be, and as the sound decays, it seems to recede into the distance. If you can get yourself into the right frame of mind when listening, this effect is actually quite striking. Striking being kind of the humorous term there. Okay, so what I'm going to do now is I'm going to have a look. We have a little bit more detail here on Safari somewhere. So I think, sorry, now I need to go back to here, and we need to just pick Safari. Oh, sorry, here it is. I'm getting a bit lost. And we go to Safari, and okay, we were looking at that this morning, but I can change that, and we'll just look at a little bit about make noise. So make noise have the QMMG. So I have a QMMG at home in my modular, one of my modulars, and you can see that it has the switch there for VCA both, and this one has a low pass and a high pass, so the VCA can be switched. So it's kind of useful because you get 4 channels, and each channel can either be a low pass filter, high pass filter, or a VCA, or a combination. So it's a very useful kind of a module. But I don't have that one in the module that I have right now, and the one that I'm using right now is this one. So this is a low-pass gate from INTELLIJEL, and you can see that this doesn't have the switch. So this can't be a low-pass filter or a VCA. This is only in that mode, the low-pass gate mode. So all you can do is ping it. All right. So if we go in, we can have a little look about what makes low-pass gates so good. Oh, I don't have it. It's in the manual here. It's only a cheap module. But if we look at it, we can see that low-pass gates are basically controlled by Vactrals. So it's got inside it, it's got an LED, a light-emitting diode, and then an LDR, a light-dependent resistor. And so as when I add in more voltage, the light gets brighter, and then the light-dependent resistor reacts to it. But it's slow. And so it's the slowness of it that we appreciate. So what happens is with an LPG, 2 things happen at the same time. It'll low pass and it will turn down the volume. So when you're gating it, it will reduce higher frequencies and volume at the same time, which is very, very like an acoustic instrument. So an acoustic instrument will lose higher frequency as it gets quieter. So think of a saxophone or something like that. And if you play a violin quieter, for example, you're not exciting the upper harmonics. So it's quite natural sounding, the LPG, which we'll hear now a minute in a demo, okay? So it's just telling you a little bit about it there. You can pause the video there and have a read of it yourself. Now, the main difference between this LPG and the LPG in the QMMG is that this LPG is a 6 dB low pass filter in it, whereas I believe the QMMG has 12 dB low pass filters in it. And I thought initially that the 12 dB would be better, but in fact this little where are we, this little 6 dB one right here, this is great, and it makes perfect sense actually, because in my mind 6 dB is like acoustic filtering, natural filtering. So you know, if you move your ears or something, it might be like 6 dB of difference as you tilt your head. And so the LPGs are trying to mimic acoustic responses. So when we hear it, we should hopefully hear that it kind of sounds like an acoustic instrument or a little bit like a reverb. All right, so are we ready to start patching, my friends? I think we might be. So what I'll do is I'll go back to my main view, and then I'll tip off this so as we can get the oscillators going. Okay, and we're going to start our patch. So the patch is going to start off, it's going to be pretty straightforward. I'm going to use this. So what I'm going to do is I'm going to create two signals to show you the difference in the tone. I'll create one that just uses VCA based, that's here, VCA based sequencing, and then I'll use another one that uses LPG based sequencing, and we can hear the both. So I'm going to create two tones, okay? And I'm going to create the sequences from them here. So the first thing that I need to do is I'm going to get two gates out, and we have these light up little cables, so that'll make it handy for us to see them, and we should see it lighting up there. And we'll put the first in here, and we can see it lighting up. And then I'll just zoom so as you can see what I'm actually doing here. I'm just going to the, just move it a little bit, there you go, a little bit better, my giant hands. And then we put that into the trigger as well. So we have two gates out now, and the next thing that I'm going to do is we're going to send two CV pitches in. So I'm going to take the pitches. So we've got one, it's just long enough. So it's got one CV pitch, and we'll go here, and I'm just going to use it to put it into the FM, okay? And then we've got another CV pitch, and that's coming out of this one here. So sequence B, and I'm going to put that into this oscillator. So now both oscillators are being sequenced from here. Okay. We're not hearing it yet. Okay, so the next thing that I'm going to do is we'll set up one of them. So this, I suppose we'll make this one the LPG, and I'll make this one the normal one. So we'll start the LPG first, I think, just so as you can get a listen to it, okay? So what I'm going to do is I'm going to take the output of this oscillator. I'm not going to tune them today, guys, because we just want to hear the tone, all right? And it's mostly percussive. So I'll put that one out. So we do the LPG first. So it's going to go into the LPG. So I'll just zoom in on the synth so we can take it. So I'm taking out of the oscillator, and I'm going into the LPG, the low pass gate. And then what I'm going to do is we just want to make sure that we're on the right one, that we're pinging the right one. Yeah, so we're on these two here. And so I'll just ping this one with this. And then what I'll do is I'll take the output of this and we'll put it into my amp, and we should hopefully hear it now. Oh wait, no, we're not getting pinged for some reason. Oh my gosh, that's okay. The gate was too long, so we show up the gate. Okay, so what I'm going to do is I'm going to ping it. And already you should be able to hear that lovely acoustic. Yeah? That lovely acoustic sound. So you can see that I've almost no envelope. Zero envelope. And all I'm doing is pinging it. If I could even get a stronger ping to send into it, I would. And it does actually matter whether the slope is exponential or linear. Get a little bit more pingy. So what I'll do, just so as you can hear the difference, okay, is I'll just move everything over to the VCA patch. All right, so we'll go in, out, and then we can hear this patch. Nothing. So you can hear that doesn't have any, that's the actual length of the delay. So everything else that we were hearing after that was the LPG, the ping. So you can see that I have to open this up, and it just sounds like a normal VCA. There's no spectral quality to the volume. All right, really tight, but there's no spectral volume. So we'll continue over, and I'm just going to continue on, my friends. So we'll just put this one into the LPG. Big difference. So next thing that we're going to do is we may as well just set up the other one, okay? So I'll get the output of this one, and what I'll do is I'll stick it into one of these filters over. I'll stick it into the filter over here, and then I'll take the output of the filter. I'll stick it into the voltage controlled amplifier. I'll control an amplifier with this envelope, and then I'll take the output of the envelope and I'll put it into one of these outputs here, okay? Okay, it's hard for me to hear it now, guys. So what I'm trying to show you is that they both have different colors, and when I'm using them together, I'm trying to create something kind of percussive. I can also use this to control the filter. Okay, so that's all I'm going to do for today, guys, on the low pass gate. I wanted you to be able to hear some of the difference between VCA gating and low pass gating, and this module is absolutely gorgeous. Even though it's only a 6 dB, it's much nicer because it does actually simulate acoustic spectral gating much more closely than a normal VCA gate. So if you have a modular and you don't have an LPG in your modular, you're missing a trick. They're really cheap and they're really nice sounding. And if you're stuck and you just, you've got no extra filter and you just need that little bit of extra color, it's lovely. And in fact, I might just try and get another one because they're absolutely gorgeous sounding. Okay, my friends, that's it for this stream. If you've got any more questions, that particular question came from a subscriber, a friend of mine, really. So thanks very much, Phil, for asking the question. But if you've got any more questions for me, ask me. And I'm a little bit like ChatGPT. I will try and answer the question as best I can. Okay, my friends, that's it for this video. Thanks for watching. That's LPG's low pass.